Okay, so excuse me. Last lecture, we looked at the simulation you see in front of you, where we were taken and we created two parts. We assigned various things to them, including a picture of the entity. We assigned it an entity type, and we assigned it a priority. So that was sort of the focus of this part of it. The other thing that we did then was have a route station module set up, where we have a route module. Again, this is an exponential. Hold on just one second here. Okay, so I'm back. So the other thing that we introduced here is the route and station module. Pretty straightforward. Again, as the name implies, it's really just to move parts from one place to another. And that's why I've got Princeton and Bluefield sort of signifying that there's two plants that are involved with this, and this is where you would use this. So it's non-value added time by definition. You establish a route time, in this case an exponential distribution of 20 minutes to get from Princeton to Bluefield. Main thing is you tell it the destination type, which in this case is a station, and the station name, which you establish, and then the station name you affix to the station module, as you can see here. So pretty straightforward, useful, non-value added, sort of separates things out from a process, but allows you to input time into it. That's really what we're trying to do here. Without having a process which consumes resources, we want Umbrella consume time, in that it takes time to get from one place to the other, but do it in a non-value added, non-resource added way. And then finally, we just had another process here, which was basic kind of stuff that we've done all along. The other two pieces to the puzzle here that we added were the plot functions, which again had a couple questions on this. Where the heck did you find that plot function? And I can't find it, to be honest with you, up here in the menu bar, but it is over here in a graphics bar that is part of the main toolbar. And there's two of them that are useful. There's a histogram or bar chart kind of bar graph kind of arrangement, and then finally the plot, which is what we used. And there's others as well that you can mess around with if you have a desire to. But the plot function is very useful in that I can keep an eye on something like the building of a queue. If I just look at the little T-bar here, obviously that gets filled up pretty quick, and I can't really do much with it after that. So having the plot is very helpful. I'll just double click on this. Again, setting it up, the source data is probably the most critical thing. You name it whatever you want, number of parts, A, and I named A because we have a B as well. And then I'm looking at an expression, which they give you some examples of things that you can look for, or you can keep track of. The creation of parts, the disposal of parts, number in, number out of a process. Or you can build your own, which is what I did, and I used NQ, or number in queue, and then the name of the queue. So this one was process AQ, and this one was process BQ, because that's obviously for process B. So that's pretty much all there is to it. I don't think I really spent maybe enough time on this last time around. The other thing is you can define some things for the axes. You need to click on the axis, whether you want axis X or axis Y. And then the one thing that you may have to change here is the increment count, so you can get a good picture of what you're doing. The auto scroll, I just leave it true, and that's about it. So the other stuff's all just sort of presentation things with colors and whatnot, which for what we're doing here doesn't really apply to any great extent. I know there was some difficulty in getting this to run, and I think part of it may be that there was a couple of different, okay, that was random, exponential. There's a couple of things where we had schedules set up for arrival times and for the resources. The other thing, which is a little weird here, weird in a way, I guess, is I've got this set as an expression. Reason being is, as I was sort of playing with it, I had an actual expression in here, but then I changed that to 3 minutes. Essentially, this becomes then the same as having a constant at 3 minutes. They'll behave in the same way. So that was one thing. What else did I do here? There was one other place. Oh, yeah. So we had this set process A. We had it cyclical. So the establishment of a set is something that I think we've talked about a little bit. The difficulty with it is that with this current version of Arena, basically you're setting it up much like you do a schedule. The set I have is blank right now, but the schedule, if you look at this for a second, what used to be a really nice graphic bar graph that I could easily bump things up and down over a period of time has become a somewhat cumbersome thing to use. And what that is you've got various steps in your schedule, and you define a value, in this case minutes, because my time units are minutes. Step one is 8 minutes and has a duration of a minute, or the gap between it rather is 8 minutes and has a duration of a minute, and so on. So it's much more cumbersome to try to deal with. You can do it with resources or with arrival times. Neither one of them really does much. I don't think really works very well. So you can go back, and this is what we did with one of you folks that had some issues, and we went back and just changed this to a resource. And unless we're keeping track of dollars, it doesn't really matter too much how you do a resource. So for what we've been fooling around with so far, we haven't done much with that, and that may change a little bit. So if you have trouble running this, you might want to just go back and change the process A, and I think process B was set that way as well. Change these just to a plain resource rather than a set, because I really don't think it really works all that well at this point. So that's just fine. And then go ahead and just let's make sure it still runs, and it does. And you can see the resources showing here. This one's sort of running away still, and that's because I messed with my times a little bit. So this will probably, yeah, like I say, this will definitely run out of entities. Again, I exceeded my 150 entities in the system. And that's just because I need to tweak my times a little bit. Let me close that. So if I go into my resource and just change this to, let's make this 1. You got to slow down the arrivals or speed up the processing. Either way works. I'll just change this to 2. So just a point on this, I'm sort of randomly changing things here, and that's okay for what we're doing. But in reality, that's probably not what you would want to do. You'd probably want to look at the process and see if you can tweak it to get it within those parameters, or go back and reduce the number of parts coming in, because you're sort of just, if the process can't really do this, is what was my point. If we're looking at an actual process and trying to simulate it, whatever this process is, if it's drilling a hole or if it's machining a part or molding a part or making a hamburger or whatever it is, if the process can't keep up with the times I'm giving, then it's sort of futile to put these in here. But for purposes of what I'm doing now, we're not really focused on an actual process. We're sort of making this stuff up. So we will get into that a little bit later, though, where we'll do some actual process stuff, and we'll have to address that a little bit differently. So let me just go ahead and save this again, and I'll hit go, and there we go. So we're still a little out of whack because it's climbing too fast. Let me stop that again. Let me just look and see how we're creating them. So random of 3 minutes. Again, constant every 3 minutes. But I have 2 coming in, both coming through the process. So this needs to be a little bit faster than the 2 of those combined. I'll make this 2. And I'll make this, let's just say 0.5. Another point here, be cognizant of your decimal points. I saw an error, not an error, but just it was typed, a little typographical error where there was an extra decimal point here, and it gave a very bizarre error. It didn't point you to what was actually happening. So just be aware of that as well. And now let's see what happens. Yeah, there we're looking a little bit better. It's still climbing, but it's coming back down. Although it's still climbing pretty fast. Yeah, same thing. One more try at this. Let me slow this down a little bit. See, when I had, instead of having a resource, when I had that set in here, I had multiple resources in play. And I could do that here as well. I could change this and, well, I got to keep the units the same. I could add a second, resource to this if I wanted to as well. But let's see if this works. I just want to get it to where it'll run to completion. This 150 minimum is a bit annoying, to be honest with you. All right. Some of this may be the priority too. Let me change this. I'm going to change this to a let me get rid of that. Let me change this back to this, and I'm going to change this to a constant. And I'll leave that at 4, just to make sure that expression is acting the way it should act. It's 1 entity per arrival, so that should be okay. And look at this one. Yeah, again, I'm not really sure why. These numbers would tend to make me think that this should run. Not really sure what. Let me just look at my resource panel here. Fixed capacity. Oops. Let me just move this up a little bit. Resource 1, fixed capacity. Per use, 0 rows. Yeah, this should be fine. I'm not really sure what the issue is. See, again, I could do by schedule, but I'm not. I'm just fixed capacity. I mean, an easy way to change this, well, I'll make it infinite. Should definitely run then. Let's just try that just for the heck of it. Move this back down a little bit. So we can see the graph. Let's move this down a little bit more. Okay, let's go ahead and run that again. There you go. So that's infinite capacity, right? So of course you have no, you really can't have a queue, and that's what I wanted to see if that would happen, and it did. Okay, so that the logic's working. Not sure why it's acting a little weird. Let's go ahead and change this to like 2. Instead of infinite. So infinite, I mean, that's just, what I did there is just a way to sort of debug something and look at it and say, well, you know, I'm building this queue. If I make an infinite resource, it won't build at all. So let me do that and just see if that, if it still behaves the same way. All right, let me save that again. Yeah, there we go. Okay, so I doubled the resource, and now it's sort of bouncing around. So that's good. So it should run now. I think I had this set for 1,000 minutes. We're at about almost 400 here, so that should finish pretty quick. But you can see the queue's really never going over 5. This one pretty much the same way. The reason is I think this one is set significantly faster. So whatever happens here, as long as this is faster than it, you won't build a queue there really either. And it should get to 1,000. Boom, there we go. Okay, let's look and see what we got here. Categories by replication. Let's just take a look at that. Yeah, see, we're still insufficient in terms of our statistical validity. So we would need to run it longer if we were really interested in this. But these are just sort of cooked up numbers anyway. So let's go ahead and move on to something else. Okay, so we got that to run. That's good. Go back to the window, run mode, and just exit that out. And save it, and we'll call that a day. Okay, give me 1 second here. I'm going to call up another simulation. That actually, let me find it rather than waste your time here. Hold on 1 second. I'm not sure where I have it stored, but give me a second. I'll be back. Okay, so this just a bit of review here. We've used the decide module I think pretty much just this one way, which is to make a sort of a two-way by chance or even an n-way by chance decision, meaning that the way I have this set up here, this is a fast food thing, create an order. You want a cheeseburger, you want chicken. If you want a cheeseburger, you prepare the cheeseburger, and if you want chicken, you prepare the chicken, right? So that's pretty standard, and the decide module just decides if it's 50%, the true leg, which you can see here, 50% of the entities coming in go out the true leg, 50% go the false leg. I changed that to 90, 90% go true, 10% go false. So it's useful, but and maybe for this it's actually fine. Again, just an assign module like we had, I assign a entity type of cheeseburger, make it a box here, the picture rather, and here I make it a picture, is a picture, and I assign chicken as an entity type. So, but the point being, this is the way we've used assign modules, or decide modules rather, I'm sorry, up to this point. So another way to do it, and really the subject of what I'd like to do with our next exercise is to use it a little bit differently. Whoops, wrong one, hold on. Well, I'll get it right in a second here, hold on. There we go, Q1, okay. So in this example, we use this considerably differently. If we go through this just really quickly, we've got a car entering the toll plaza in our crate module, and we've got again a decide module, which I'll come back to, and then we have three process modules: an easy pass, exact change, and full service, and then finally exit the toll plaza. So what we've done different here is what we're looking at. We're sort of looking ahead, if you will, and we've got, so the way this works, n-way by condition, if the first expression is correct, it takes this route. If the second is correct, it takes this route. If neither one is correct, it takes the last route. So it's sort of if-else Boolean logic. So if the first line is true, it takes this route. Second line is true, takes this route. And then if neither one is true, in other words, else, it takes the last route. Okay, so and what it's really looking at, it's looking at, again, this is the reason I brought up one of the reasons in the last exercise I plotted the number in the queue is because I knew we were going to use that later. And that's exactly what we're doing here. So we're looking at the number in the queue, and we're saying, is that less than, see if I can stretch this out so we can see the whole thing. Is that less than, I can't do that, can I? Huh. Give me 1 second here, maybe if I edit it. There we go, okay. Just be careful we don't change it. So what we're saying here is that if the number in the easy pass queue, in other words, that's this queue, is less than the number in the exact change queue, then the condition that we have is such that we will take this path, okay? But we're not just interested in this one. If we said that, then we would sort of not be looking at the full service queue, which we want to look at both of them. So what we want to do is we have three toll booth stations. We have a queue in front of each, and we want to pick the one that's got the least number of cars in it, right? So we need to look at not just this, but also this versus this. So we compare easy pass queue to exact change. Is this less? Yes. And is it also less than full service? If that's the case, that's where the car goes, to the easy pass. Okay. Let me just hit cancel, and I don't want to change it. This one we can see. And then the second thing is, if the full service queue is greater than the exact change queue, okay, then it goes this way. So if this is less than this and this, it goes here. If that's not true, then we know that this is greater than this, so we don't need to look at it again. But we do need to look at the full service queue and see if it's greater than the exact change queue, okay? So it's sort of inverted the logic a bit there. But what that does essentially is, if this is got more than either of these this will not be true. So then we go to this next step, which is here. And if this is greater than this, then we go here, okay? And if neither one of these is true, meaning that this is greater than this and this is greater than this, and this would probably, well, yeah, it could be either way, that this would be greater than the easy pass or easy pass would be greater than exact change. The logic would still work. Then we go full service, which is the else. So if neither one of these is true, in other words, that this is greater than this and this, and so in other words, this is greater, easy pass is greater than exact change, as well as full service, and that full service is less than exact change, and by default, less than this, then that's the else branch, and it goes out this way. So that's quite a mouthful. Hopefully that makes some sense. But sort of think through the logic. It's sort of basic Boolean type logic, and can be quite useful for applications like this. So let's go ahead and see if this will run. I haven't actually tried this yet today, but nothing has changed, so hopefully it will. I didn't change anything, so I'm not going to hit save. Let me grab that phone. Hold on one second. Okay, so I'm back. Sorry for the interruption there. Let me go ahead and hit run here and see what happens. Speed it up a little bit. Okay, so you can see queues building. Yeah, let's see what this looks like. Number out. Interesting, this correlated at 300 minutes. Really depends on the interrelationship between the statistical distributions that you select as to how long it takes to correlate, meaning that you're statistically valid. I want to look at here. Entities in, entities out, queues. That's what I want to look at. Here we go. So waiting time at the EasyPass queue, 11.85. I don't know what I did on the timing on that. We need to look at that in a second. I don't remember what I set up for a distribution. Interesting, the waiting time on the exact change and the full service queue were both pretty low. I'm not sure what the grill queue is. It must have been a leftover from a previous distribution or previous simulation. Let me see what we did here. So we had, let me stop that just so we can see a little bit better. Stop it. There we go. So we had a triangular 3, 5, 7.5. That's probably not really right. Actually, let me see what the other ones are. We might have the timing backwards on some of this. Yeah, 0.5, 1.5. Yeah, 0.51, 1.5. So that we were probably playing around with this. This is something I actually used last year when I taught it. So I think we should probably change these, and we can change it down here, or we could change it in the. This would actually be faster, I would say. So let me make it faster. EasyPass, I mean, you're just going through at supposed to be 15 miles an hour or whatever it is. Where here you got to make some sort of a stop unless you've got the ability to throw the coins pretty well. And then full service, obviously that should be the longest. Let's make that longer. I would think that could be probably at best a minute. Make this 2, make this 3. So again, I'm not sure if you've used this, but again, looking at the processes in this format, if you're trying to really evaluate the relationship between the three, this is a nice tool to use. It's a good view of the data. It's the same data that you're going to find in the modules, but you can see them all at once and sort of see how they line up relative to each other. So that's a useful tool there as well. Let me just save that. Let's hit go, see what we get. And that makes a little bit more sense. I believe we had the longest queue here, if just based on the leftovers. And we go back to queue. That makes a little bit more sense. EasyPass still had a longer waiting time. That's interesting. Number weighting. Let me just double check, make sure that that actually worked out that way. Yeah, that's 0.5, 0.75. What did I do with resources? I don't know why I have a resource in there named grills. That's interesting. All right, that's why we're seeing a longer time. We've got the resources a little goofed up here. Let me go back and change this away from a set. I don't know where it pulled this from, to be honest with you. The new version of, as I mentioned, of Arena doesn't handle sets and schedules real well. And I have no idea where it got that from. So let's go ahead and edit that. And we'll make that into a resource. And we'll call that, I think we have, what do we have? 3. We'll make that resource 1. And we'll just click OK. OK. And let me save it again. And let me start it again. It runs pretty fast. Yes, I want to see that. And we'll go to queues again. Yeah, now that's making a little bit more sense. So our waiting time is the least on EasyPass queue, which it should be. The processing time is the least. Full service being the most. Again, that makes sense. Number waiting, again, that tends to drive that to, right, that would follow my logic. So the point there is that the way you have resources set up, especially if it's in a set, if it's a consistent resource, it won't do that. But if it's in a set and it gets a little out of kilter, you can wind up with no resource. And that's probably what was happening, which is why these numbers initially didn't really sort of jive with what we would expect. So that seems like that's a little bit better now. That's good. Let me stop this thing. And let me just save it. And we could, if we wanted to, we could set up a plot. If we whoops, wrong one. Could do a histogram too, I suppose. So we need to pick a data series. I'll go ahead and add one. Actually, get rid of that one. And we'll call that number in EasyPass Q. And the expression, I got to see what that is called, if it's going to come up with number in, number out. Yeah, it doesn't give me that as a, so I can build an expression. So I just went to expression builder just in case you missed that little quick click there. Current number in Q is what we're looking for. Exact change Q. Not sure why I picked the exact change Q. Let's make it the EasyPass Q. There we go. I guess it doesn't really know where I am. So EasyPass Q, got that set up. Let's just take a look and see what the, not that, the axis. Left axis, why? Well, we don't want both, right? Left value. So you could plot two values, I guess. That might get a little confusing, although I suppose if you set your colors up right or whatever, you could plot both of them. But let's keep it simple here. Let's make that 1, because I don't think we had too many. What were we running in there? Well, let's run it like that. Let's just see what it looks like. And we'll set that up over here. We can make that a little bit bigger, maybe. Let's just run it, see what happens. What's the worst that could happen? Here we go. Okay, so I probably want to change this. I'm not sure what the, that's probably 1, 2, probably going up and down. Let me just stop that. And no, I don't want to see that. I'm going to exit this. I'm going to change this and go back into my axes, my left axis value. And I'm going to change my major increment to 1. And change this again, hit save, hit go. There we go. So now it's you can see it's bouncing between 1 and 2. So that's pretty useful. And again, I think I could plot multiple things on this if I wanted to. I didn't want to see that. Didn't want to do that. Why did I do that? So I could either put the other cues in there. I might get a little bit busy. I might be better off with 3 smaller plots. I can move this up, I think. It's not really cooperating with me. This up too. I don't want to do that. There we go. All right, so I'll create another plot just for the heck of it here. This one will do exact change. So again, don't click on histogram, wrong one. Click on the plot. There we go. We're going to add a data series. We're going to call this one number in exact change queue. Whoops. Act change queue. Again, there's not, if I just wanted one of these, I could just select it, but that's not the case. So I got to build an expression. I'm going to go to queue. I'm going to go, and I could look at average number, current number. What I really want is current number. Again, and this time that is what I wanted. If not, I just click that, right? Still have a grill queue there. Not really sure what that's all about. No, not that. Exact change. Bang, there we go. All right, so that's that. I'm going to go back to axes again, and I'm going to get rid of this right value. Not really sure why that seems like that's a default now, which is okay, I suppose. But and I'm going to change this to 1 because we know that major increment doesn't work. So that's it. And I'll just line this up right underneath this one. There we go. And let's go ahead and do this one, do one for the full service queue. Well, let's just run it, just make sure it works. Always good to save and run just to make sure that things haven't gone crazy. That looks pretty good. You can see this is really tightly spaced. If you space this out a little bit, you get more of a, more distance in the x-axis between the points. But this tells us what we want. This is really what we're into. Although with this, since the number in the queue is so small, you can pretty much see it really just with the, really just by looking at the little icon there. All right. Well, you can't move these directly, but must be a way. All right, let me go ahead and stop it. I'll go ahead and do the last one. So again, I'll click on the right icon this time. Plot. Again, data series I want to add. What do I want to call it? I want to call it number in full, service queue. And again, I need to do an expression, and it doesn't have the data for whatever reason. It doesn't show that number in the queue. You think since I did it twice it might, but it doesn't. So you need to go to, again, to build expression. And now these are all different, just to take a step and look at this. There's all different things that all different types of expressions that I can build using distributions, different math functions, different replication variables, different entity related variables, attributes, if I'm changing my attributes, right? I can look at all these different things that I can change about the entity. I can assign numbers, assign serial numbers, all different types of things that can be useful, date and time type stuff, which can be useful as well. So we'll try to get into that a little bit more. But right now, all I'm really looking at is the queue, and I want my current number in the queue. This time I want the full service. Okay. Again, I'll go back to my axes. I don't really want this one, but I do want this one. And I'm going to change this to my major increment to 1 again. So that's just basically the scaling of the y ordinate numbers that are on there is all it is. So that's okay. And I'll see if I can drop this in here. sort of keep it lined up a little bit. And that's that. Let's go ahead and save that and run it. And there you go. So it gives us some useful information. Again, this is just an example of what you can look at. You can look at all kinds of things. As I said, things coming in, things coming out, all kinds of time things in terms of processing time, in terms of wait times. It really solely depends on what kind of process you're looking at in terms of what's important. And I think I'd used this example before where in this type of an application, right, what I really care about is how long it's going to take me to get through. If it's going to take me, if I have an easy pass, especially, so I've gone out of my way to purchase an easy pass, and it takes me 15, 20 minutes to get through the toll booth, and it's not caused by traffic on the opposite side. You know, I'm not going to be pleased, right? So that's a characteristic of the process that you would really want to take a hard look at. Conversely, on a manufacturing operation, I don't really care that much normally about the time it takes for a part to get into the machine. I care more about my maximum maybe in the queue, because now I'm creating work in process, and also the throughput. That's probably my biggest thing that I want to take a look at and understand and optimize. So, okay, so that's a couple of more features here. Again, looking at just to review for a bit. We've got a decide module, n-way by condition. Let me stop this so we can see this right. Hang on one sec. There we go. Again, n-way by condition, meaning multiple ways. I think you can have at least 5 or 6 we had used in various applications before. And putting in an expression that basic Boolean, it's basically a Boolean algebra type setup, where you're using the number in the easy pass queue being less than the number in the exact change queue and being less than the number in the full service queue. And then that's the direction that the entities will go. If that's not true, you drop to the second expression. And if that, in this case, is the number in the full service queue greater than the number in the exact change queue, if that's true, it takes the second path to exact change. If neither one of those are true, in other words, it's if-else logic, then that else path takes me to the full service queue. So that's the basis of this, and pretty useful. And again, you can look at all different types of things in doing this, not just numbers in the queue. Okay, so that is sort of as far as I want to go today with this. What I'd like you to do is basically utilize this and take what I've got here and create a process. Maybe let's go to a slightly different process. Why don't we go back to maybe a manufacturing operation, and let's say we've got parts coming in to a decide module, and then those parts get sent to a processing station. Let's say I've got 5 drill presses. Let's see if we can get up to 5 drill presses that will all do the same job. So I want to route the part to the one that's got the lowest number in the queue, and then process it from there. So if we can go ahead and do that, basically following what I did here, but just work through the Boolean portion of that logic to make sure that the part actually goes to the one with the least number in the queue. So sort of follow what we did here. And then instead of looking, and then use our plots again, and instead of looking at the plot for the number in the queue, let's look at processing time, maybe overall, and then you could maybe plot some other variables. Just use your imagination a little bit. Number in the queue is fine, but maybe there's some others that would be more applicable to a manufacturing setup. So, but I want to make sure we sort of get this down, this n-way by condition. That's sort of an important piece. Okay, so that's it. Just to reiterate, if you are having troubles or issues, or are stuck on something, or don't understand something that I've presented, reach out around campus, and most of the time. And if not, you can give me a call or email me, and I can arrange to be on campus whenever you're available. So don't struggle alone. That's not the purpose of this course. What we're trying to do is really get you a tool that you can utilize once you get out of school and get into industry, because simulation is a very useful thing. The one other point, so that's the homework, and again, just reach out if you get stuck. The last thing I wanted to point out too was you saw on this, and I don't really know how these resource allocations got mixed up, but in some way they did. It could be because of the new version, and it doesn't really like sets and schedules so much. But you saw how that affected the, sort of counterintuitively affected the logic or impacted the output, right? The logic was saying one thing, but the output we were getting didn't really follow that. So just a point to look at the resource allocations. If you wind up, especially with a schedule where you have 0 resources at some point in time, it's going to impact your queue tremendously. And a debugging tool, which I showed you earlier, to sort of help with that sometime is go into your resource table, which is, gotta close that out, which is over here somewhere. Go into your resource table and just make that, instead of fixed capacity, make it infinite. Or instead of capacity, rather, make it infinite. Just click on infinite. And that will get rid of any impact of a resource on the queue. So that's just a little debugging tool. Obviously, you don't want to leave it that way because you don't have, typically don't have infinite resources in any real world application. But in terms of trying to debug the simulation to get it to run right, that can be helpful. So okay, so we'll get this posted here tonight, hopefully, or not first thing in the morning. And appreciate your attention. We'll talk to you again on next Wednesday. And from here on out, we are going to go online only. Reason being, I don't have a problem meeting with anybody, on campus to go through things, but I sort of need to deliver the same message to everybody, to be fair. And I struggled with trying to do that with an in-class as well as an online version of this. So I felt like the best way to do that was just do online. That way everybody's getting the same information and the same format, and hopefully that makes the most sense. But again, I have no problem meeting with anybody outside of class, even on the phone. If you're some of you may not live even within the area, so give me a call, email me, whatever, and we'll figure any issues that you might be having out. So again, have a good week.